proof. We prove this result by the method of contradiction. Okay, for a small information, what is the method of contradiction is that if we have only two results in front of us, that is either this or that, then we will move by the method of contradiction. That is, for the real numbers, there are only two categories, that is either rational or irrational. If something is A is a real number, then A can be either a rational number or an irrational number. So we apply the method of contradiction. That is, we are moving in such a way that root 3 is a rational number. Okay, our assumption is that root 3 is a rational number and we are finding something wrong in our way, and we will assume our assumption is wrong, then we will prove root 3 is an irrational number. Okay, so you must take in mind that is in order to move by method of contradiction, there are two and only two choices in front of us, either this or that. Okay. Next, we are moving as in previous question, that is, if root 3 is rational, then root 3 equal to p by q, where p and q are integers, and HCF of p and q equal to 1. That is where p and q are coprimes. Coprimes are the number having HCF 1. Okay. Then, similarly, in the next previous problem, we are squaring. Then 3q square equal to p square by squaring on both sides. Okay. Then what is here p? P square. P square is a multiple of 3, or 3 divides p square here. As in the previous problem, 2 divides p square here. What will divide p square? 3 will divide p square. Okay. 3 divides p square since p square is a multiple of 3. Okay. Then what is by our theorem? If p square is a multiple of, if 3 divides p square, then 3 divides p. By the above theorem. Then what is p? P equal to, p is a multiple of 3, then p equal to 3c. Once again, why p is a multiple of, why 3 divides p? Since p equal to, p is a multiple of 3. Okay, that is p equal to 3 into something. That is, if p is a multiple of 3 means 12 is a multiple of 3, that is 12 equal to 3 into some 4. Then what we can conclude? 3 will divide 12. Okay, here if 3 divides 12, what we can write? 3 divides p, then what we can write? P equal to some 3 into c, that is 3 into a quotient c plus remainder 0. Then if p equal to 3c, we are applying this here, that is in p square, what we will get? 3q square equal to 3c whole square. That is, instead of p, we are providing 3c whole square, which is equal to 9c square. Then on cancelling 3's, what we will get? Q square equal to 3c square. Okay, that is q square is a multiple of 3, or 3 divide q square from this step. Then what about by above theorem? By above theorem, 3 divides q. Q is a multiple of 3. Okay, then q equal to some 3c or 3k. That is, if 3 divides q and 3 divides p, then what we can conclude? P and q have a common factor, that is 3. That is, if p and q have a common factor which is 3, then then our assumption is wrong. Why? We got something wrong in our way, that is HCF of p and q is 1. Why we take HCF of p and q equal to 1, but we got p and q have other common factor which is 3. So HCF cannot be 1. It may be 3 or greater than 3, which is a contradiction to fact that HCF of P and Q equal to 1. So in our part we have got something wrong here. So what we can conclude? Our part is wrong. That is, our assumption is wrong. Hence our assumption is wrong. So what is our conclusion? Root 3 is an irrational number. Okay. So here we write by above theorem. In the time of examination, you have to mention which is that theorem. Okay, you have to write that theorem clearly in the time of your examination. Don't write by above theorem like that. Okay, you have to keep that in mind.